We have to prove that m squared minus n squared equals to 4 times square root of m times n, whenever m and n are given by the following trigonometric equations. So let's begin for whatever we have been provided with. So first we note down the value of m. So we're given that m value that's equals to tangent of theta plus sine theta, and n value, so that's equals to tangent of theta minus sine theta. So we'll start from the left hand side. So on the left hand side we have m squared minus n squared. So our m value, so that's tangent theta plus sine theta whole squared minus tangent theta minus sine theta whole squared. Now m squared minus n squared, we know that. Let's note this down here. If we expand this is simply the product of m minus n and m plus n. So that means we are going to get tangent theta plus sine theta minus tangent theta plus sine theta, which is going to give us 2 times sine theta multiplied to tangent theta plus sine theta plus tangent theta minus sine theta, giving us 2 times tangent of theta. And this value will be equals to 4 times sine theta times tangent theta. So this is our expression on the left hand side. We'll keep it aside. Now we will work with our m times n. So we have m multiplied to n, so this will be equals to, so we have tangent of theta plus sine theta whole multiplied to tangent of theta minus sine theta. This could be now rewritten as tangent squared theta minus sine squared theta. Now we know that the tangent function is the ratio of the sine over cosine function. So tangent squared theta can be expressed as sine squared theta divided by the sine squared theta minus sine squared theta. Now if we take sine squared theta as the common factor, so we have sine squared theta multiplied to 1 over cosine squared theta minus 1, which will be equals to, so this is the value of mn, so this will be equals to sine squared theta multiplied to, now 1 over cosine squared theta, that's secant squared theta. That's because the secant function is the reciprocal of the cosine function. So we have secant squared theta minus 1. This will be then equals to sine squared theta multiplied to tangent theta, tangent squared theta. That's because we have a standard identity 1 plus tangent squared theta having a value of secant squared theta. So this is the trig identity that we have used. So we have replaced secant squared theta minus 1 with tangent squared theta. Now that we have the value of mn, so we can take the square root on both sides. So square root of mn will be equals to sine theta times tangent theta. And we are going to multiply both sides with 4. So we have 4 times square root of mn equals to 4 times sine theta times tangent theta. So now we see that m squared minus n squared has a value of 4 times sine theta times tangent theta, and 4 times square root of mn also has the same value. So we can say, hence we can say that m squared minus n squared, so this is equals to 4 times square root of m times n, hence proved.